Hello and welcome to this class. We just want to use this short class to work on this quiz given to identify the sides of these triangles, the unknown sides of these triangles. Let's start with triangle number 1, solution. Solution number 1. Now let's draw the triangle again. Triangle number 1, let's draw it again. That is this. Now we are going to have this. Now this we have here, this is perpendicular, this is 4, this is y, this is 7, this is 3, and this is x. Now the first thing for us to do is to identify the triangles inside this big triangle. For us to identify it, we have to number all the points. Let's start with this point. Let's call this place A, point A, this place B, this place C, and this place D. Now let's bring out the triangles, the sides that have 3 sides. So we have triangle ABC is a complete triangle. So we have triangle ABC. Now we have another triangle ACD is another triangle. So we have triangle ACD. So we have 2 triangles inside this big triangle. The big triangle is triangle ABD. Triangle ABD is the big triangle. Then inside it we have triangle ABC and triangle ACD. Now looking at this triangle, line BCD is a straight line. It is a straight line, and we know that the angle in a straight line is 180. The total angle in a straight line is 180. Now since this angle here is 180, is 90 degrees, and the total angle in a straight line is 180, it means that the angle that will be here is 180 minus this one, which is 90. 180 minus 90, which is 90 degrees. So it means that this angle here is also 90 degrees. That means that this place is also perpendicular. Now it means that ABC is a right angle triangle and ACD is also a right angled triangle. So we have 2 right angled triangle inside this big triangle. Now we can now use Pythagoras theorem to find the unknown sides. We are looking for x and y. Now for us to find the unknown triangle, the unknown side, we have to have 2 sides that are already known. So going to the triangles, let's look for the one that has 2 of its sides already known. For ABC, we know line BC is 7 and line AC is 4. Okay, so we can use this one. Now let's check the other one. For ACD, we know AC as 4 and DC as 3. Okay, so we have 2 sides already known in both triangles. So we can start with any one. Well, let's start with triangle ABC. Now for triangle ABC, for triangle ABC, for triangle ABC, triangle ABC, for triangle ABC, now the side that is facing the angle 90 degrees is called the hypotenuse. For ABC, it is Y or line AB that is facing the angle 90 degrees. So Y is the hypotenuse, while the other sides are the adjacents. So we have that y squared, according to Pythagoras theorem, is equal to AC squared plus BC squared. So we have AC is 4 squared plus the other side is 7 squared plus 7 squared. Now that means that y squared is equal to 4 squared is 16 plus y 7 squared is 49, and we have that y, this is equal to 16 plus 49 is 65. So y is equal to root 65. Root 65, if we divide by 4, it will not go. If we divide by 9, it will not go. If you divide by 16, it will not go. If you divide by 25, it will still not go. So I'll just find the root straight. If I find the root straight, I'm going to get 8.06. So y is 8.06. Now let's look for x. Now for x, we use the other triangle ACD. Now the side that is facing the angle 90 degrees is line AD, which is x. So x is the hypotenuse. Now while the other sides are the adjacent. So x squared is equal to 4 squared plus 3 squared. X for triangle ACD. Now we have that x squared is equal to 4 squared plus 3 squared plus 3 squared. So we have this is equal to 16 plus 9, which is equal to, this is equal to 25. So x squared is equal to 25, and x is equal to root 25, which means that x is equal to 5. So our y is equal to 8.06 and x is equal to 5. So this is the answer. This is the answer for this. Now for question number 2, the triangle is, this is the triangle. Okay, let me draw it. The triangle is, this is a triangle. Now we have here as Q, and we have here as 7, we have here as 12, then we have here as R, and we have here as 5. Now again, the first thing for us to do is to identify the points and bring out the triangles inside this big triangle. So let's start with this place A, B, C, and D. Now we bring out the triangles inside this. We have triangle A, B, C, and we have triangle A, C, D. Triangle ABC and triangle ACD. Now we start with the triangle that has 2 sides. For us to solve, we have to start with the one that has 2 sides. And again, looking at triangle at line BCD. BCD is a straight line, and this side is 90 degrees, which means that this side is also going to be 90 degrees because it is a straight line, 180 minus 90. So that means that line for ABC, line AB is equal to the hypotenuse, that is Q is the hypotenuse, and for ACD, R is the side that is facing the perpendicular side. So R is also the hypotenuse. Now let's look for the one that has two sides already known, and then we start solving from there. Now for ABC, we know line BC as 7 and line AC as 12. For ACD, we know line AC as 12 and line CD as 5. So we can start from any one we like. But let's start from ABC. Now for ABC, for triangle ABC, for triangle ABC, now let's start with the first one, ABC. So Q square is equal to 12 square plus 7 square. Q squared is equal to 12 squared plus 7 squared, which means 144 plus 49. 144 plus 49, that means that Q squared is equal to root 193. Root 193, if we try to divide, we will not get it. So let me just find the root straight. It is equal to 13.92. If you still leave it as this, it is still okay. If you divide to get to the smallest number, you still get it. But I just decided to divide it. Now, if you get to this point, anything you've gotten is correct. Once you got this, the examiner will give you your full mark. But if you can break it by dividing by 4 and checking by 9, 16, 24, and so on, all the perfect squares, then it is okay. But if you get to this point, you can also find the root direct or leave it like this. But if you want to use it to solve another question, it is important you leave it like this, or you can still divide it to get the final answer. So Q squared is equal to this. This is equal to this. Then this is Q. Q squared is equal to this. And Q is equal to this, which is equal to the Q now is equal to this plus this, which is 13.92. So this is Q, not Q squared. All right. Now we solve for R. Now for R, for line A, triangle ACD, for triangle ACD, now we know that R is the hypotenuse, ACD, R is the hypotenuse. That means that R squared is equal to 12 squared plus 5 squared. So R squared is equal to 12 squared plus 5 squared. Now this is equal to 144 plus 25. This will give us 144 plus 25. This will give us 169. Okay, and R now is equal to root 169. Let me just divide, get the root straight. If you get the root straight, it's going to give us 13. It is 13. So the answer for this is 13. Now, we have gotten the Q and gotten the R. So let's move to another number. Question number 3. Okay, this triangle, this, okay, not triangle, four-sided shape. Let me see how it looks. Okay, now let me draw. Okay, so we have something that looks like number 3. It looks this way, this way, this way. A kite, and you have this. Now you have this. Okay, all right, and we have this place. Should be this place is perpendicular. This is x. This is 8. This is y. This is 4, and this is perpendicular. Okay, now we label and identify the triangles inside this. We can start from here. Let me start from here. A, B, C, D. A, B, C, D. Okay, so these are the points there. Now let's try to bring out the right-angled triangles inside it. Is the right-angled triangles that we're working with using the Pythagoras theorem. So for ABC, there is a perpendicular side, which means that it is a right-angled triangle. Now ADC also has a perpendicular side, so which means that we have two right angle triangles inside this. In short, we have two triangles inside this shape. So we have triangle. The triangles inside this, we have triangle A, B, C, and we have triangle A, D, C. So these are the two triangles here, and two of them are right angled triangles. Now for triangle ABC, the side that is facing the perpendicular side is this side, which is line AC. So line AC is the hypotenuse. While for triangle ABC, the side that is facing the right angle triangle is line DC. The side that is facing this is this, while the side that is facing this is this. So AC or X is a hypotenuse, while DC or 8 is another hypotenuse. Now let's start with the first one, line triangle ABC. Triangle ABC. Triangle ABC. Now for triangle ABC, we have that x squared is equal to, okay, we have which sides are given to us. For ABC, we know BC as 4, we don't know AC, and we don't know AB. So we cannot start with this. I think there's something I missed in the labeling. Okay, we have 6 here. Okay, so let me put it. We have 6 here. 6. Okay, we have 6 here. Okay, now for triangle ABC, We know line AB as 6 and line BC as 4, so we can start with it. For ADC, we know line DC as 8. We don't know AC and we don't know AD, so we cannot use triangle ADC to start it. We are going to start with triangle ABC. Now for the triangle ABC, the hypotenuse, which is x squared is equal to 4 squared plus 6 squared. For triangle ABC, we say that x squared is equal to 6 squared plus 4 squared. So we have that this is equal to 36 plus 16, and that will give us x squared is equal to 52, and it now means that x is equal to x now is equal to root 52, which is equal to root 52 is going to give us this is going to give us 2 root 13. This is going to give us 2 root 13, right? That is 13 times 4. 13 times 4. Yeah. 13 times 4, which is equal to 2 root 13. Let me x is equal to root 52, which is equal to root 13 times 4. X is equal to 2 root 13. Let me get the final distance since we are going to use it to solve another question. This will give us 7.2. I can use it like this. I can also leave it like this. Either way, if you stop here, you get your full mark. If you solve it to this, you still get your full mark. Okay, now we now have that our x is 7.2 or 2 root 13. Now for the other one, for triangle ADC, now we now know our line AC as 2 root 13. So this place is now 2 root 13. Now for ADC, it means that we now have 8. We now know line DC and we know line AC. So we now have 2 sides. So we are now going to look for line AD, which is Y. Now which one is the hypotenuse? 8 is the hypotenuse side, line DC. So 8 squared is equal to 2 root 13 squared plus the other side plus y squared. So we are now going to have that for triangle ADC, 8 squared is equal to 8 squared is equal to 8 squared is equal to, let's say, 2 root 13 squared plus 2 root 13 squared plus the other side, which is now y squared. 8 squared is equal to 2 root 13 squared plus y squared. Now 8 squared minus 2 minus 2 root 13 squared is equal to y squared. That means that y squared, just transform it, is equal to 8 squared. 8 squared is equal to 64, and 2 root 13 squared. If we have 2 root 13, we have squared. If you want to clear this square, use this power to times the square roots and use it to times this one that does not contain square roots. So it's going to be 2 squared times root 13 squared. Now this is going to be 2 squared is equal to 4 times 13. 4 times root 13 squared. Root 13 squared, like I've said before, anytime you see a root a squared, this power will cancel the roots to give you a. If you have b here, the power will cancel the roots to give you b. So no matter anything you have inside the square roots, if you have power, the power and the root will cancel to leave only the number. So this one now, the power, the square will cancel the square will cancel the roots to get 13 alone. So we are now going to have that this is equal to, okay, that is 4 times 13, yeah, 4 times 13. So this is going to give us, this is now going to give us that y squared is equal to, this is equal to, that is going to give us 64 minus 52, right? 13 by 2 is equal to, this is 26 plus 20, okay, all right, 52, all right. So we are now going to have that y squared is equal to, y squared is now equal to 12. Y squared is equal to 12, and our y now is going to give us root 12. Now root 12 is equal to 3. 3, right? Point what? Let's leave it root. This is root 12 is equal to 3 times, this is equal to 3 times 4, now which is equal to 2 root 3. Now this is going to give us 2 root 3 as the answer. So we have that our y is equal to 2 root 3, while our x is 2 root 13, 2 root 13, and the other one is 2 root 3. Okay. Now we have another one. We have number 4. Number 4 is this structure. Okay, let me look at it very well. Now let me draw it. Now we have number 4. For number 4, we have this, we have this, no, we have this, we have this, we have here, we have here 11, we have here, I think we have something like this, no, okay, yeah, B, no, all right, whatever. So we're not going to have this place is y, this place is 7, y this place is 5. Now let's identify the triangles inside this. The triangles inside this, for us to identify, let's label. Let's start with this place, A, B, C, D, E. So we have 5 points inside this. So let's identify the triangles. We have triangle A, triangle ABC, triangle ABC. It is a right angle triangle. Triangle ABD, triangle ABD is a right angle triangle. We have triangle BCD, but triangle BCD, there is nothing on both sides of it, 2 sides of it, so we are not going to work with it. This side is empty, so we can't use it to do anything, so we just ignore it, but it is a triangle BCD. So let's look for D, or let's just write it out. We have triangle BCD. Now you have triangle ADE, triangle ADE. The ones that are relevant to us are triangle ABD and triangle ADE. Now let's look for the ones that are right angle triangles. Triangle ABD, it has a particular sign, so it is a right angle triangle. Triangle ADE, it has a perpendicular sign, so it is also a right angle triangle. Now among these 2 right angle triangles, which one has 2 sides? So that we start from it. Here is X. Okay. Now for ABD, we only have one side, AB, which is 11. We don't know line BD and we don't know line AD. For ADE, we know line DE as 5 and we know line AE as 7. We are looking for line AD. Line AD is X. Now which side is the hypotenuse? Which side is the hypotenuse here? The hypotenuse now is the line facing the angle 90 degree, which is 7, line AE. So line AE squared, that is 7 squared, is equal to x squared plus 5 squared. Now for triangle ABD, we have that 7 squared is equal to x squared plus 5 squared. 7 squared is equal to 5 squared plus x squared. 7 squared is equal to 49, is equal to 25 plus x squared. Now it means that x squared is equal to 49 minus 25. This minus 25, and we are now going to have that x squared is equal to 24, and x is equal to root 24. Root 24 is 24 will give us 12 times is equal to, that will give us can we get square roots inside it? You say 4 times 6. Okay, if you say 4 times 6, yes, that is going to give us 2 root 6. 2 root 6. Okay, 2 root 6. So we have 2 root 6. We can also say that x is equal to root 4 times, let me clean here, you write it very well. X is equal to 4 times 6, which is equal to 2 root 6. Now 2 root 6 is also equal to, we can solve straight to get the value, or we can leave it as 2 root 6. Okay, let me leave it as 2 root 6. 2 root 6, that will give us 2 root 6. Now let's solve the other side. We now have this side, we now have x as 2 root 6. Now let's look for y. For triangle ABD, now we now know x as 2 root 6, and we know AB as 11, so we can get BD, that is y, since we now have two sides that are known. Now which one is the hypotenuse? Y is the hypotenuse because it's facing the angle 90 degrees. So y squared is equal to 11 squared plus 2 root 6 squared. So we are now going to have 4 for triangle A B triangle ADE. Is it ABC? We've solved ABD. Now for triangle ABD. Okay, triangle ABD. For triangle ABD, now we have that y squared is equal to 2 root 6 squared plus 11 squared. That is, this y squared is equal to this side squared plus the value we got here squared. So that is now going to give us y squared is equal to 2 root 6 squared is the same thing as 2 squared times 6 according to what I explained before. So that is the same thing as 4 times 6. 4 times 6, and 4 times 6 is the same thing as 24. So we have 24 plus 1, 2, 1. 24 plus 1, 2, 1. So this is going to give us 24 plus 1, 2, 1, and that is going to give us 1, 2, 5, 1, 1, 4, 5. That's going to give us 1, 4, 5, 1, 4, 5. Therefore, y is equal to root 1, 4, 5, of which we can leave it like this, or we solve it to get, if I find the root of this straight with my calculator, it will give me 12 points, 12.41, 12.41. Okay, 12.41. So this is yx is 2 root 6. So we've gotten this 2 root 6 is the same thing as 7.2, right? I think so. I think it should be something like 7.2. No, it can't be. It should be around 4.9, around 4.9. So we can leave it like this, or we get the final value for it. Now, for the last one, the last one is this structure. Okay, let's draw it. Okay, to draw that we have number 5. Number 5, we have this, we have this, we have this. No, let me clean. Is it? Okay, no, we have okay, so we have something like from here go to this side. Now we have this place as have a perpendicular side here. This place is 5.5, while this place is y, and this place is 5, this place is 2, and this place is x. Now again, we start by bringing out the triangles in this. Let's number. Let's call here A. Let's call here B. Let's call here B. Let's call here B. And let's call here C. So we have, okay, we have a point here. This is B. B. We have a point here, C, and we have a point here, D. So we have numbered all the points. Now let's bring the triangles. We have triangle A, B, C. Triangle ABC. We have triangle, the main triangle itself. Let's start with the main triangle, which is triangle ABD. Triangle ABD. Now you have triangle ACB. ABC, and you have triangle ACD. Now, among all these triangles, which ones are right-angled triangle? Triangle ABD, which is the main triangle, there is a perpendicular sign there, which means that it is a right-angled triangle. Now, triangle ABC, ABC, ABC is not a right angle triangle because this side it is not given. We don't know whether it is 90 degrees or not, so we cannot take it as a right angle. It is not a right angle triangle, so we are not using the triangle ABC. We are not using it. Now, we don't know whether this angle here is 90 degrees or not. So we don't know whether it has angle 90 degrees or not. And since there's no angle 90 degrees in it, it is not a right angle triangle, and we cannot use it to solve using Pythagoras theorem. Now, triangle ACD, it has right angle triangle again, the one for the main right angle, for the main triangle, for the triangle ACD. Okay, so we have two right angle triangle inside this in this triangle. Now for triangle ABD, how many sides are known? We know side BD. Side BD is equal to 2 plus 5. From here, from D to C, from B to C is 5, and from C to D is 2. So the total from B to D is 5 plus 2, which is 7. Now, AD is X, we don't know it, and AB is Y, we don't know it, so we cannot start with that one. Now for triangle ACD, CD is 2 and AC is 5.5. So we have two sides that are known in this one. So we can start with this. We start with triangle ACD. For triangle ACD, we have that which side is the hypotenuse? The side that is facing the angle 90 degrees, which is, this is the angle 90 degrees. The side that is facing it is this, which is AC, 5.5. So we have that 5.5 squared is equal to the adjacent, that is the other side squared, that is 2.2 squared plus x squared. Okay, so we have that 5.5 squared is equal to 2 squared plus x squared. Okay, now it means that x squared is equal to 5.5 squared minus 2 squared. And this is going to give us x squared is equal to, if we do that, it's going to give us 26.25, and that means that if we find the root of 22.25, it's going to give us that x is equal to root 26.25, which is equal to 5.1. So x for this triangle is 5.1. Now we look for the other one, which is this x is 5.1. Now we look for y. Now for y, it is under the big triangle ABD. ABD. Now BD is 5 plus 2, which is 7. We know this side now as 5.1, that is x. Now we now know two sides, so we can get the third side. Now which side is now the hypotenuse? It is the side that is facing the angle 90 degrees, which is y. So y squared is equal to 7 squared plus 5.1 squared. That is for triangle ABD. Triangle ABD. For triangle ABD, triangle ABD, we have that y squared is equal to 5.1 squared plus 7 squared plus 7 squared. So that will give us what is it going to give us? That is going to give us that y squared is equal to, it will give us around 75.2, and that means that 75.2, that means that y is equal to root 75.2, which is equal to, y is equal to 8.7. So y is equal to 8.7, yx is equal to 5.1. So we have solved all the questions there. That is how to solve for this. Just pay attention to know the right angles inside the shape that is drawn. Identify them from the ones that already has two sides that are known. Start with that and get the value. The value you get will help you to get the other values that you are looking for. Thank you.